Hello guys, welcome back on Sagacious Learners. So in this video we're going to be talking about mass-mole relationship on chemistry. So first, what is mass-mole relationship? The mass-mole relationship is an essential concept in chemistry that links the mass of a substance to the number of moles of that substance. This relationship allows chemists to perform calculation involving the amount of element or compound in a chemical reaction. Understanding this concept is crucial for solving many chemistry problems, from balancing chemical equations to determining how much of a substance is needed in a reaction. So here are some key concepts to understand. First, what is a mole? A mole is a quantity in chemistry that represents 6.022 times 10 raised to the power 23 particles of a substance. These particles of a substance can be either atom, molecules of ion. So in equation, they may ask you to calculate the particles, or they'll ask you to calculate the mole, and they'll give you the atoms, or they might give you in molecules or in ion. So you can classify these three as particles. This number is known as Avogadro's constant. This number here, 6.10 raised to the power 23, is known as Avogadro's numbers. The mole concept allows us to count atoms or molecules in a given sample, just like a dozen counts 12 items. So this mole, as we said before, mole or mass-mole relationship. Let's say 1 mole of carbon is equals to 12 gram. So this is telling us that if you bring 1 mole of carbon, 1 mole of carbon will weigh 12 gram, telling us that it has 12 gram. So imagine a bag of rice. If you say 1 bag of rice, and let's just assume that 1 bag of rice will weigh 12, or let's say 1 bag of rice will weigh 150 kilogram. So we can now go ahead and say 1 bag of rice is equals to 150 what gram or kilogram. We can also say that 1 bag of rice is also equals to 6.022 times 10 raised to the power 23. This is assumption. So this is how this works. 1 mole is equals to 12 gram. You can also see that 1 bag of rice is equals to 150 gram. 1 bag of rice will weigh 150 gram. And this one bag of rice equals to 6.022 times 10 raised to the power 23. This is an example. This is not actual in what this is in real life. But let's solve for chemistry. As we see here, 1 mole of carbon is equals to 12 gram. So the relationship of mass, mole, and particles. The relationship between mass, mole, and particles can be summarized by the following formulas. So mass to mole conversion is given as number of moles is equals to mass of substance in grams divided by molar mass in gram per mole. So which means that we can use this formula to solve the number of moles if we have the mass, because molar mass is always constant. Remember that I say that 1 mole of a gas or 1 mole of a substance should weigh something. Look at what I mean. 1 mole, for example, 1 mole of carbon is equals to 12 gram. This means that if you bring 1 mole of carbon, 1 mole of carbon should be giving you 12 gram. So this is how this works. So let's solve for mole to mass conversion. So to convert this mass, provided that you have the mole in the equation, so you're going to just go direct and make this the size of formula. So making this mass of substance the result of formula, we're going to cross multiply. So cross multiplying, we now have mass of substances now equals to number of moles times molar mass in gram per mole. So moles of particles, they can give you atoms, molecules, or ion in solving questions relating to mass mole relationship. So if they give you atom or molecules or ions, we are also generally talking about particles. So number of particles is equal to number of moles times 6.022 times 10 raised to the power 23, which this represent the Avogadro's constant. So if they ask you to calculate the mole, when they might give you atom, or they might give you molecules or ion, and they ask you to calculate the mole, just make mole the source of formula. So to make mole the source of formula, we want to just go straight to the point and divide the equation by 6.022 times 10 raised to the power 23. So here will now become 6.022 times 10 raised to the power 23. So these two things we cancel, leaving us number of particles divided by Avogadro's constant, which is 6.022 times 10 raised to the power 23. So since we have basic understanding of this, let's dive into problems solving questions relating to mass mole and particles relationship. So consider this question: how many moles are in 24 grams of carbon? So we can use two ways to solve this. First, we can use the mass mole relationship, or we can use the formula method. So first, let's solve with the mass mole relationship. So solving with the mass mole relationship, we have that 1 mole of carbon is equals to 12 grams. And they ask us how many moles are in 24 grams. So since we don't know how many moles are in 24 grams, we're going to just write here to be x is equals to 24 grams. Why? 1 mole of carbon is equals to 12 grams. So x mole will now give us 24 grams, because in the question they're asking us how many moles are in 24 grams. So in solving this kind of question, you are going to use what we generally know. We're going to first write out the mass mole relationship of that element or compound, which is not changing or varying, is always constant. Then you're not going to implement one of which they give you in the equation. As you can see here, here is constant, here now is constant, nothing is changing. If you should bring 1 mole of carbon, 1 mole of carbon you weigh 12 grams. So then I'm asking you, since 1 mole of carbon you weigh 12 grams, so how many moles are in 24 grams? So how many moles will weigh 24 grams? This is the meaning of this question. So we now say x mole will weigh 24 grams, since we don't know how many moles will weigh 24 grams. So while solving this question, always notice something, that the mole are always one side, and the grams are always in one side. Let's consider this. In question like this, if you say 1 mole will give us 12 grams, you cannot come and say 24 grams and I give us s mole. It's wrong. Reason: because mole is here and mole is here, so it's absolutely wrong. So the mole should be at the one side of the equation, while the grams you are looking for should be at the one side of the equation. So making s the source of formula, what you have to do now is to cross multiply in order to make s the source of formula. So making s the source of formula, now do 12 times s will give us 12x, and 1 more times 24 will give us 24. So dividing here by 12 in order to make s the source of formula, you now have that s is equals to 2 moles. So this simplifies that 24 grams actually will give us 2 moles, or 2 moles will weigh or become 24 grams. So let's solve this using the formula method. Using the formula method, we have that Number of moles is equals to mass in grams and molar mass in gram per mole, or this can also be expressed as gram per mole. So in solving this, so since we have our mass to be 24 and our molar mass is always there, nothing is changing, so the molar mass of carbon is 12. So moles will now become our mass, which is in the question, 24 over molar mass, which is now 12, because carbon, 1 mole of carbon is equals to 12 grams per mole. So 24 divided by 12 will now give us 2 moles. So let's practice more questions. What is the mass of 3 moles of water? So we're going to solve this using two formula. First, let's solve using mass mole relationship. So 1 mole of water is equals to how many grams? So hydrogen, 1 mole of hydrogen, 1 mole of hydrogen will weigh 1 gram. But since hydrogen has 2 as its subscripts, so we're going to multiply this times 2, giving us here now 1 mole of hydrogen now give us 2. And hydrogen is always diatomic, which means it always have 2 subatoms. So oxygen, 1 mole of oxygen is always equals to 16 gram. So 1 mole of water is the combination of hydrogen and oxygen. So with 1 mole of water give us what? 1 mole of water will now give us 2 plus 16. Reason, because water is made up of the combination of hydrogen and oxygen. We got water from hydrogen has a charge of +1 and oxygen has a charge of -2. So this reacting with this will now give us hydrogen. This plus sign will go for the oxygen, and this -2 will now go for the hydrogen, giving us H2O. So it's the combination of hydrogen and oxygen. And since 1 mole is now equals to hydrogen plus oxygen, and hydrogen plus oxygen has molar mass of, hydrogen has molar mass of 2 and oxygen now has molar mass of 16 from the combination of them to form water. So we now have 1 mole is equals to 2 plus 6, which is 2 plus 6 is equals to 18. So which means 1 mole of water is equals to 18 grams. So how many moles of gram? So how many 3 moles of water will now produce how many mass? So 3 moles of water will produce S mass, S gram, because we don't know how many mass will be produced. So from this, will the mass be at the left hand side or at the right hand side? And where will the mole be? Will the mole be at the left hand side or at the right hand side? The mole will be at the left hand side due to we put 1 mole is equals to 18 grams. Why the mass will be at the right hand side, since 18 grams is at the right hand side. So you cannot have mole and mass in the same side and have grams and mole in the same side. Is very, very, very wrong. You are going to have mole in the same side and mass or grams in the same side. So how many will 3 moles produce how many grams? As we said, if you put in this 3 here, is wrong, because gram is here and mole is here. So you cannot implement this 3 here. Where you are going to write this 3 is here. Reason, because mole is there, gram is not there. I hope this shouldn't confuse you, and don't make this if you are writing or preparing for exam. So with 3 moles give us what? Since we don't know what 3 moles will give us, we can now use S. Here can be any variable, here can be S, here can be Y, here can be Z, because we don't know how many moles will 3 give us. Now, how many mass will 3 moles of water produce? Is now to make this the source of formula. So making S the source of formula is just to cross multiply. So cross multiplying, we now have S is equals to 3 times 18 is now 54 grams, which means that S will produce 54 grams. So let's solve this using formula method. In using formula method, we have that mole is equals to mass in grams over molar mass. Molar mass. So since we have our mole, which our mole is 3, and we have our water, our molar mass of water, which I've explained before. So our molar mass of water is 18, and we are looking for mass. I'm going to just go straight to the point and make mass the source of formula. So making mass the source of formula, we now have mole, where our mole is 3. This is now mole dot molar mass. This is molar mass. Let this not confuse you. So what is our mole according to the equation? Our mole is 3 times what is our molar mass? Our molar mass is 18, because hydrogen is 2. Hydrogen has molar mass of 1 times 2, so we have 2 plus, and oxygen has 16, so 2 plus 16 is 18. That is how we have this 18. So 3 times 18 will now give us 54 grams. So let's solve more questions relating to this topic. How many molecules are in 2 moles of water? How many molecules are in 2 moles of water? So we can solve this in 2 ways, using mole-molecule relationship or using our formula. So first, let's use our formula. So our formula told us that number of particles is equals to number of moles times our Avogadro's constant, which is 6.022 times 10 raised to the power 23. So they are asking us how many molecules are in 2 moles of water. So how many molecules, as we see, particles can be molecules, atoms, or ion. So number of particles, we are talking about number of molecules also. So number of particles will now become 2, since we have our moles to be 2, times 6.022 times 10 raised to the power 23. So 2 times 6.022 times 10 raised to the power 23. We now have our number of moles to be 1.2044 times 10 raised to the power 24. So we can also solve this using mole-particle relationship. So how does this work? You can just go straight to the point and say 1 mole is equals to 6.022 times 10 raised to the power 23. So how many molecules, where this 6.022 times 10 raised to the power 23 is representing our particles? So they're not asking us how many molecules are in 2 moles of water. So here is now 2. Reason, we're going to put this 2 here. Reason, because this mole is here, so 2 will be here. And since the molecules is in the right hand side of the equation, so we're going to put S. Since you don't know whether how many 2 moles of water will produce how many particles, so I'm going to use S, or you can use any variable of your choice. So making S the source of formula, you have to cross multiply. So cross multiplying, you now have S is now equals to 2 times 6.022 times 10 raised to the power 23 is equals to 1.2044 times 10 raised to the power 24. You see, using mole relationship and using the formula are also giving us the same answer. So you can now use any of your choice. So let's practice some questions. Since you now have basic understanding of this, so I will not use the two method. I'll just go straight to the points and use one of the method. So which is 1 mole is equals to 6.0. 1 mole is equals to 6.22 times 10 raised to the power 23. And how many moles are in 3.01 times 10 raised to the power 24 molecules of water? So that the question was how many moles. So how many moles here will now become S mole, since you're looking for mole and mole is in the left hand side. So the particles there is 3.01 times 10 raised to the power 24. So next is to make S the source of formula. So making S the source of the formula, 1 mole we multiply 3.01 times 10 raised to the power 24 and 6.022 times 10 raised to the power 23 we multiply S in order for us to make S the source of formula. So this multiplying this, we now have 6.022 times 10 raised to the power 23. X is now equals to 1 times 3.01 times 10 raised to the power 24 is also the same thing. So we now have 3.01 times 10 raised to the power 24. So next is to make S the source of formula. So to make S the source of formula, we have to divide the left hand and the right hand side of the equation by 6.022 times 10 raised to the power 23 in order to bring out this integer S. So here divided by 6.022 times 10 raised to the power 23, and here we now divide 6.022 times 10 raised to the power 23. So 6 divided by 6 times 10 raised to the power 23 we cancel out. So S will now become this divided by this. So 24 cancel 23. If you apply law of indices, since the base are the same, I'm going to just do 24 minus 23. Or you can just go straight. If this will confuse you, just go straight and use your calculator. So 24 minus 23 will give us 1. And 3.01 divided by 6.022 will now give us 0.4998 times this. So here now become 0.498 times 10 raised to the power 1. So we now have 4.998. So approximating this, we now have 5.0. So how many moles? So this will now become moles, which means 3.01 times 10 raised to the power 24 we produce approximately 5.0 moles. So summary of key formulas. So since you have known this, use this and practice many questions you have come across based on mass-mole relationship. This question is very necessary and which you must see in any exam you are preparing for. So summary of key formulas. Recall that mass to mole is number of mole mass in gram over molar mass, and mole to mass is mass, making mass the sole formula, which this go here, which is number of mole times the molar mass. So moles of particles, which can be atom, molecules, or ion. Number of particles is equal to number of moles times 6.022 times 10 raised to the power 23, which is the Avogadro's constant, and number of particles to mole. So to find mole, if they give you particles, you should just divide here by 6.022 times 10 raised to the power 23, dividing both sides with this. So we now have this number of particles, because this we cancel. So we now have number of particles all over 6.022 times 10 raised to the 3 is our number of moles. I hope you understand these parts. So let's dive in to more complex parts based on mass mole relationship. Here we're going to calculate the limiting factor, or the one that is completely used in the equation. So let's consider this problem. Given that ammonia, we all know, is NH3, is synthesized from nitrogen and hydrogen according to the following balanced equation. From this, so if 10 grams of nitrogen gas reacts with 3.0 grams of hydrogen gas, how many grams of ammonia are produced? We expected to just go straight and dive in and use nitrogen or hydrogen to find this ammonia. But to find this ammonia in these two elements, which is nitrogen and hydrogen, one is completely used and one is in excess. So what we are going to do is to find ammonia that is formed, we are going to use the one that was completely used up, not the one that was in excess, because the one that was in excess will remain. So I'm going to use the relationship between the one that was completely used up and the formation of ammonia. That is why we are not going to just dive in and solve. So in this kind of problem, what we are going to first and identify is the one that is completely used up and the one is in excess. So once we find the one that is in excess, we're going to just drop it to one side and use the one that is completely used up. So nitrogen reacts with hydrogen to produce ammonia, and from the equation we have 10 grams of nitrogen. 10 grams of nitrogen. Record that 1 mole of nitrogen is equals to 14 grams. So with 10 grams yield how many moles? So 10 grams will now become S mole. So 14 times S is equals to 10, and S is now equals to 10 divided by 14. So 10 divided by 14 is equals to 0.7143. So this is the mole of nitrogen. So let's write it, because this will be very useful. 0.7143 moles. We're going to use this to determine the one that is in excess and the one that is completely used up. So to calculate for hydrogen, so we can now say 1 mole of hydrogen is equals to 1 gram. So with 3 moles be equals to how many gram? Will be equals to how many gram? So this 1 gram will be multiplied by 2. Reason, because hydrogen is diatomic. Hydrogen exists as H2. So 1 mole of hydrogen is equals to 2 grams. So with 3 grams yield, 3 moles yield S gram. And where is this 3 moles coming from? This 3 moles here is coming from the equation. From the equation we have that hydrogen has 3 moles and nitrogen has 1 mole. So that is why we used 1 mole is equals to 14 grams. And 1 mole is equals to 2 grams. And we are using 3 moles now is equals to S gram. That was a mistake. So since 1 mole of hydrogen will give us 2 grams, so from this question they said 3 grams of hydrogen gas. 3 grams of hydrogen gas. So S mole will now give us 3 grams. So how many moles will be produced? So making S the solve the formula, we now have 2S is equals to 3 and 2 over 2 to 3 will now give us S is now equals to 1.5 mole. Therefore, we now write hydrogen as equals to 1.5 moles. So we're going to use this to determine the one that is in excess and the one that is completely used. So to determine the one that was in excess, we're going to solve this using the equation. So from the equation, we have that 1 mole of nitrogen reacts with 3 moles. Here is 3 and here is 1. So 1 mole of nitrogen reacts with 3 moles of hydrogen. So 0.7143 moles will react with X. This 0.143 is gotten from this. Remember that I said I'm going to use this to find the one that was completely used or the one that was in excess. So 0.7134 will produce S mole of hydrogen. So what is the mole of hydrogen that will be produced? This 10 is just trying, listen, this place is just trying to tell us that how many, if 1 mole will react with 3 moles. So 0.7143 moles. We're using the 0.7134 moles because they said 10 grams reacted with what? 3.0 grams. So 0.143 moles will react with X. So will 0.7134 he would have many moles, or with 0.7143 moles of nitrogen required how many hydrogen? That's what this thing is saying. Since the total mole of nitrogen that reacted is 0.7143. So yes, that's trying to tell us how many moles of hydrogen will 0.7143 require. So making this the sort of formula, we now have S is now equals to 0.7143 times 3. We now have 2.1429 moles, which means that 0.143 moles will produce 2.1429 moles of hydrogen. That's 0.73143 will require 2.1429 moles of hydrogen. So if we solve for hydrogen and hydrogen is greater than this, which means that hydrogen is in excess. But if hydrogen is less than this, which means hydrogen is completely used up. This tells us that in this reaction, 0.7143 moles of nitrogen will require 2.1429 moles of hydrogen for this reaction. So let's go and solve for hydrogen. So from the equation, we have that 1 mole of nitrogen will react with 3 moles of hydrogen. So how many moles or 1.5 moles of hydrogen will now produce how many moles of nitrogen? So from here we have that hydrogen has 1.5 moles because they say 10 grams of nitrogen reacts with 3.0 grams of hydrogen gas. So this 3.0 grams is equal to 1.5 moles. So here is S mole of nitrogen will react with 1.5 moles of hydrogen gas. So making S the sort of formula, we now have 3s is equals to 1.5. So 1.5 divided by 3, we now have 1.5 divided by 3. We now have that s is equals to 0.5 moles. So therefore hydrogen was in excess and nitrogen was completely used. So we can now use the nitrogen to find the grams of ammonia. So to find the grams of ammonia, we are going to say we are not going to use mass mole relationship for ammonia and for nitrogen and for ammonia. So from here we have 1 mole. So 1 mole of nitrogen we produce how many grams? So we're not going to include these two because this two is mole. What we're looking for is the standard gram of ammonia. So 1 mole of ammonia is equals to, nitrogen is 14 and 14 times 3 because hydrogen has 1 plus the subscript of 3. So 1 times 3 will now be 3. So here will now become 17 gram. So 1 mole will give us 17 gram. So from here 1 mole of ammonia will produce 17 gram. I'm not adding this 2 because this 2 is 2 moles. We are looking for the what 1 mole of nitrogen will produce how many moles, we produce how many gram in gram per mole. So 1 mole of nitrogen will give us 17. So 0.7143 mole of ammonia will now give us s gram. Recall how we got this 0.7143 mole. Will now give us s because nitrogen was completely used. If that hydrogen was completely used, we should have used hydrogen instead of nitrogen. So since this is in gram, this is gram, and this is mole, so I can now go ahead and make s the source of formula. So making s the source of formula, we now cross multiply. So s will now become 17 times 0.7143. S will now become 12.1431 gram. So this is equals 12.1 gram. So this is the gram of ammonia produced. Let's solve more questions. So consider this equation. Ammonia is synthesized from nitrogen and hydrogen according to the balance equation. N2 plus 3H, which is 2NH3. If 5.0 liter of nitrogen gas at standard temperature reacts with excess hydrogen gas, how many grams of ammonia will be produced? So the question is how many grams of ammonia, which is this, will be produced. So for us to calculate this, since they give us only nitrogen as the parameters of nitrogen as only the reacting agents, they didn't give us anything about hydrogen. So we're going to just go straight and use nitrogen. We're not going to find the SS and the one that is limited or the one that is completely used because they gave us information containing only nitrogen. They didn't give us both of them. But to find the mole of this, we have to first convert this liter to dm cube. So I will tell you why we are going to convert this to dm cube. Because to find the mole of nitrogen that will react with this will be equals to N is equals to V over 22.4 dm cube. So this is in dm cube. So this must be in dm cube for us to have our mole. Or if you cannot use this, you can also use this and also say 1 mole. 1 mole is equals to 22.4 dm cube. So S mole will now give us what? We don't know. So this is what you will use to solve in this kind of question. So how we arrive at that formula, we can say since 1 mole is equals to 2.4 dm cube, so S mole will now give us volume, and they give us this, but this is in liters, so liters and dm cube will not work. We have to convert, is either we convert this to liters or we convert the liters to dm cube. So I will choose to convert our liters to dm cube, or you can also go and convert your 2.4 dm cube to liters. Anyone can go, but I'll prefer you converting liters to dm cube. So to convert liters to dm cube, we have that 1 liter is equals to 1 dm cube. So 5 liter will now produce how many dm cube? So 5 liter, making S the solve of the formula, we now have 5 will now produce 5 dm cube. So which means 5 liter is equals to 5 dm cube, since 1 liter is equals to 1 dm cube. So implementing this in the equation, now have S mole will now produce 5 dm cube. So making S this is the formula, we now have 22.4 dm cube S is equals to 5 dm cube. So S is now equals to, divide both sides by 24, we now have 5 divided by 24, 2.4. We now have that S is now equals to 0.2232 mole. So this is our S. Since now our S is 0.22 mole, we can now go ahead and use mass mole relationship or mole relationship to solve this. So the question was, how many grams of ammonia will be produced? So recall that we have 1 here and we have 2 here. So recall that 1 mole of nitrogen is equals to 2 moles of ammonia. So 0.2232 moles will now give us S. So making S shows the formula. Now I have S is equals to 0.2232 times 2. We now have S is now equals to 0.4464 moles. So since we have the mole of ammonia now, we are just going to go straight to the point using our formula. Mole is equals to mass over molar mass. So since we have our mole and we have our molar mass, where our molar mass is 17, remember that nitrogen is 14 plus 3 is now 17. So this is now equals to mole. What is our mole? Our mole is 0.4464 times our molar mass, which is 17. So our mass will now become 7.589 grams. So, but we can also solve this in another way. You can also solve this using our direct mole mass relationship. So using our direct mole mass relationship, where you have here is 1 and we have here is 2. So 1 mole of nitrogen will produce how many grams? Recall that to calculate mass is mole times molar mass, and you have our mole to be 2 and our molar mass is 17. So 2 times 17 will now give us 34. So we have that 1 mole of nitrogen will produce 34 grams of ammonia. We got this 34 from gram per mole of ammonia is 17 and nitrogen is 2. So 1 mole will produce 34 and 0.44 0.4464 mole we now produce S, making S the source of formula. We now have S is equals to 0.4464 times that's 4 is now equals to S is now equals to 7.589 grams. You see, you can decide to use this and you can also decide to use this. Anyone must just know what you are doing and what you are looking for. So consider this problem. In the reaction of magnesium with hydrogen chloride and hydrogen gas are produced according to the following balance equation, which is this equation. So if 5.0 gram of magnesium reacts with 10.0 gram of hydrochloric acid and the reaction produces 4.0 gram of magnesium chloride, what is the percent yield of the reaction? We can also say what is the percentage yield of the reaction. We can also say what is the percent yield of the reaction. So to solve this equation, the formula is percentage yield is equals to actual yield over theoretical yielded times 100 over 1. So this is the formula to calculate the percentage yield. So since this is the formula, we have our actual yield to be 4.0 gram. So if you see this kind of question next time, always know or always have it in mind that theoretical yield is the one you are going to calculate yourself, while the actual yield is what they have given you in the question. So let's go ahead and solve these problems. So first, they say the magnesium reacted with hydrogen chloride, which is 5.0 gram of magnesium. So what is the mole of magnesium in this equation? So we can use two methods to find the mole. So I'm going to use two methods to find the mole. First, the mole of magnesium here is 1 mole of magnesium produces 24 grams. So S mole will now produce 5 grams. So making S the source of formula, we now have S is equals to 24S is now equals to 5. So S is now equals to 5 divided by 24. So S is now equals to 5 divided by 24. We now have 0.208. Or we can go ahead and use our formula. Mole is equals to mass over molar mass. So what is the mole? Our mass is 5 and our molar mass is 24. This is now also equals 0.08. So mole for magnesium is equals to 0.208 moles. So let's calculate the mole for hydrogen chloride. So to calculate the mole of hydrogen chloride, we can use two methods. But let me use the first method. 1 mole of hydrogen chloride. Let me write it where 1 mole of hydrogen chloride is equals to 36.5. So the question is, how did I get this 36.5? So hydrogen is 1 there and chlorine is 35.5. So 35.5 plus 1 is 36.5. So how many grams? 10 grams of hydrochloric acid will now produce how many moles? So here will now become 10 grams because here is grams. We now produce how many moles? So making S the source of formula, we now have S is 36S is equals to 10. So S will now become 10 divided by 36. So our answer will now become 10 divided by 36, we now have equals to 0.2778 moles. We can also use our formula mole is equals to molar mass. So using this formula, mole is equals to mass over molar mass, where our mass is 10 and our molar mass is 36.5. So our answer will now become 0.2778 moles. So we can now write for hydrogen chloride is equals to 0.2778 moles. So since we have this, what is the next thing? So we're going to go ahead and calculate which one is in excess and which one is completely used up. So to calculate this, we're going to use the relationship. So from this equation, you have that 1 mole of magnesium will produce 2 moles of hydrogen chloride. So 0.208 mole will now produce how many hydrogen chloride? So we're going to represent it as S. So S will now produce 2 times 0.208. So S will now produce 0.461 moles of hydrogen chloride. This means that magnesium will need 0.416 mole, or magnesium will react with 0.161 mole of hydrogen chloride. So let's calculate for hydrogen chloride. Recording this equation, we have 1 mole is equals to 2 moles of hydrogen chloride. So hydrogen chloride is 0.2778 moles of hydrogen chloride. So we now produce S. S mole will produce 0.2778 of hydrogen chloride. We now have S is equals to 0.2778. So 2 cancel 2. We now have our S to be equals to 0. These 2 we cancel themselves, and we now have 0.2778 divided by 2. We now have 0.1389 mole. So we have 0.138 moles. So what is this then telling you for magnesium? So this then is now telling us that 0.23778 mole of hydrogen chloride would like to react with 0.138, or we produce 0.138 grams. And from our mole, we have magnesium to be 0.208 moles, indicating that magnesium is in excess, because 0.2778 mole of hydrogen chloride will react or produce 0.1389 moles of magnesium chloride. But from here, we have that magnesium was 0.208 moles, telling us that magnesium is in excess. Why here we have 0.416 moles, telling us that hydrogen chloride is completely used, because this then tells us that magnesium chloride will produce 0.416 grams, but 0.2778 moles was present. Do you understand? Magnesium will like to produce 0.416 moles of hydrogen chloride, but 0.2778 moles was present, telling us that hydrogen chloride will be completely used up. So hydrogen chloride is the remitting reactant, it's completely used us, while magnesium is the one that is excess, so it will remain after the reaction. Since we have all these things, so let's go straight and find the percentage yield. But first, to calculate the percentage yield, remember that our formula for percentage yield is actual yield over theoretical yield times 100. So it will be in percentage because they said percentage yield. So to calculate this theoretical yield, since magnesium is in excess, we are going to use the one that was completely used up in the reaction, which is the limiting reactants. So it's hydrogen chloride that was completely used. So from here, we're going to now draw the relationship. So we're going to use mole mass relationship, or you can use mole, and later on you can convert it to mass. But first, let's use mole mass relationship. So from here, we have that 2 moles of hydrogen chloride will react with 1 mole of magnesium chloride. So 2 moles of hydrogen chloride will react with magnesium chloride, and we have chlorine to be 35.5, but since we have 2 in subscript of chlorine, so we're going to do 35.5 times 2 plus magnesium is 24, so we have 24. So we have that 2 moles of hydrogen chloride will produce 95 grams of magnesium chloride. So 0.2778 moles will now produce how many grams? S grams. So 2s, making s the source of formula, you're going to just cross multiply. So 2 times s will give us s, which is now equals to 0.77 times 95. We now have 0.277 times 2778 times 95. We now have 26.391. So we divide here by 2 and divide here by 2. We now have s to be equals to 26.391 divided by 2. We now have s to be 13.1955 grams. So this is the theoretical yielded, but let's solve this using another style. So to solve this using another style, so we can now say 2 moles of hydrogen chloride will react with 1 mole of magnesium chloride. So 0.27778 mole will now produce S. So 2S is now equals to 0.2778. So S will now become 0.2778 divided by 2, which is 0.2778 divided by 2. So let's calculate it. 0.2778 divided by 2. So we now have mole to be 0.1389. So we now have the mole of magnesium chloride to be 0.1389. So we are able to now invoke our formula. So recall that our formula is mole is equals to mass over molar mass. So making mass the source of formula, we now have mass is equals to, what is our mole? Our mole is 0.138, is 0.1389 times our molar mass. So what is our molar mass? Magnesium is 24 plus 35.5 times 2, which is 71. Here is 71 because we have 2 as the source script, as you can see in this question. So we now have 24 plus 71, 24 plus 71 will now give us 95 times 0.1389. So our mass will now be equals to 95 times 0.1389. Our mass will now become 131.955. So this mass is approximately 13.2 grams. So this is the theoretically yielded. We use our mass mole relationship and mole relationship, and we still arrive at the same answer, which is 13.2 or 13.1955 grams, approximately, which is 13.2 grams. So since we have our theoretical yielded, so let's recall our formula, which is for calculating the percentage of the reaction. So recalling our formula, we have that percentage yield, PE, percentage yield, or we can use percentage yield is equals to actual yield over theoretically yielded. Times 100 over 1. So what is our actual yield? Our actual yield was 4.0 according to the equation, because they say if 5.0 grams of magnesium reacts with 10.0 grams of hydrogen chloride acid and the reaction produces 4.0 grams of magnesium chloride, what's the percentage yield? So they said 4.0 grams was produced, 4.0 gram of magnesium chloride was produced. So our actual yield is 4.0 divided by our theoretically yielded, which is 13.2 times 100 over 1. So 4.0 divided by 13.2. So 4.0 divided by 13.2. 4.0 divided by 13.2 is equals to 0.303 times 1 times 100, because we want to convert it to percentage. In converting it to percentage, if you ask to convert anything to percentage, just multiply it by 100. So percentage yield will now become this times 100 will now give us 30.3%. So this is our answer. I hope you find this video helpful and enjoyable. Don't forget to like, subscribe, and hit the notification bell for more videos like this on Sagacious Learners. Good day. Goodbye.